In this recording, we're going to develop an important notational convention about definite integrals. So I want to start by drawing a picture. And the picture is one that we've seen before. We have an x-axis, we have a y-axis, and we have some kind of function y is equal to f of x here. And as always, we are going to have the start of a piece of area, which is x is equal to a, and the end of a piece of area given by x is equal to b. And I want to shade this pretty little piece of area. And we know that that particular piece of area is equal to the definite integral from a to b of f of x dx, because I'm integrating with respect to the independent variable named x. Now I want to actually duplicate that picture, so bear with me. I first of all have to select everything, and I have to group it and copy it and paste it. And now I'm going to move my duplicate copy over here. Now I want to ungroup everything on that side, and I also want to ungroup everything on this side so that we have two identical pictures. Now I'm actually going to edit this second picture. And let's see, I want to do the editing in a new color. So here's the new color. What we're going to do is we're going to rename the axis for the independent variable with the variable name t. Now that's going to change this function curve from y is equal to f of x to y is equal to f of t. And the area now is the area under y is equal to f of t, and we are integrating with respect to t. So this area doesn't get written this way anymore. The area is now written as the integral of f of t with respect to t. But remember, we just duplicated the area. So the actual areas, this area over here and this area over here, are actually exactly equal to each other. So I want to have that written down. The two areas are equal to each other. Because all I did was copy them. This one is a complete copy of that one. And because the two areas are equal to each other, that says that we have the integral as a goes of f of x is from a to b. And I didn't say that very clearly, so I'm going to say it again. The definite integral from a to b of f of x dx, that area over here, this area, is equal to the integral from a to b of f of t dt, which of course is this area over here, but we already know the two areas are the same because it was exactly the same picture. Now, there's some vocabulary associated with this fact. Because the variable of integration, and I kind of want to indicate what that particular phrase means, this x, which goes with that dt, is said to be the variable of integration. And the variable of integration in this particular definite integral is named x. But over here, the variable of integration indicated by that t inside the function and this t that follows the dt, these two things say that the variable of integration is t. And finally, this equal sign says that the name of the variable of integration is unimportant. So since the two, let's see, that is a straight mark, so I don't want to get rid of that, and let's focus in on this just a little bit better. Since the variable of integration in a definite integral is unimportant as far as the final answer goes, we call that kind of a variable a dummy variable. So we call this variable a dummy variable. And let me write that word more clearly. And it's important to realize that it doesn't matter what we call the variable in a definite integral. I could even rewrite this if I wanted to as the definite integral from a to b of f of u du, or I could write it as the integral from a to b of f of s ds. The important thing is that the function's variable and the variable after the d have to agree. And in all of these integrals, the endpoints have to agree. And as long as the endpoints agree and the function is the same, but we're simply changing the variable name, the answer doesn't matter, and that's why we call the variable of integration a dummy variable.